What would you do if you had your favorite sci-fi franchise be realistic enough to where these floating gigantic satellites with dinosaur killer guns on them has enough information on it to where I can tell you that it can delete a continent with 52 gigatons of energy, but couldn't bother to give you the dimensions of the f***ing projectile? I would assume most people who do care would just do their best and guesstimate, right? After all, you can't really mess up anything that doesn't actually exist. But this is the Onyx Plateau, and we don't make educated guesses. We write an entire thesis to make your favorite sci-fi franchise make sense, even though nobody asked. So this is how you reconstruct a tungsten projectile from completely out of thin air, knowing only one thing, and that is its mass. In this case, it's 3,000 tons. Step 0. Crack open a cold one and cry a little bit. Step 1. Translate tungsten's AMU into kilograms, which is done by using Avogadro's number. Step 2. Take the kilograms and figure out what the mass is for each cell. What does that cell look like? This fucking thing. Officially, the atomic lattice of tungsten. Unofficially, the cube of melancholy and desolation. Step 4. Figure out what the radius of a tungsten atom is. JK, we're just gonna Google that. This is already borderline in quantum physics, and we really do not need to go any further into it. Step 5. Realize that this is made up of 2 atoms, so the cell actually looks like this thing. What does that mumbo jumbo in there mean? It means there are 6 different radiuses we gotta take into account. 2 from the center and 4 from the corners, which are shared. Why are the radius and the corners shared? I don't know, man. Why don't you got some bitches on your dick? Both of which have a really good answer, but is outside the scope of this video and would take too long. Step number 6. Do the Pythagorean theorem, but evil. Why is that important? It's to figure out the distance between one atom and the other. Why is that necessary? Because we're trying to find the volume. Step 7. Find the volume. JK is to find a cell volume. Step 8. Find the actual volume of the projectile. And what is so important about the volume? It tells us what the maximum metaphorical empty space that the projectile will have on the inside of it, which will help narrow down the infinite possibilities of shapes it could be down to a million different kinds of shape and sizes it could be instead. And since I don't have the patience to run all 1 million scenarios, we're going to use a 10-to-1 ratio instead, 10 being height, 1 being width. Most projectiles are usually something along the lines of those ratios anyways, so this works out. And at the end of it, what is the result? We get the diameter of 2.7 meters, a height of 27 meters, and an area of 229. And what does that look like in real life? About the average size of a blue whale. So what did we learn today? If there's a will, there's a way. Just because it doesn't exist doesn't mean we can't make it exist, at least on paper. If for any inexplicable reason you want to try this yourself, please be sure to color code everything. A lot of the stuff you solve for in there comes full circle, so be sure to take really good notes. More of these Who Asked videos are on the way, so if you're one of those people who did ask, like and subscribe.